In another video, we talked about earthquakes and the destruction they can cause when they happen on land. Today, we're going to look at what happens when they happen at sea and cause something known as a tsunami. This is an enormous amount of water moving very quickly, and it can destroy anything in its path. In recent years, there have been two large devastating tsunamis. The first was on December 26, 2004. Near Indonesia. It was a huge earthquake under the water, out at sea, an earthquake with a magnitude of 9.1. This was the largest earthquake to happen for 40 years. The earthquake caused a tsunami that travelled faster than an aeroplane and killed more than 200,000 people. The other huge tsunami that happened in recent years was in 2011 in Japan. In March of that year, a magnitude 9.0 earthquake hit, just off the coast of northeast Japan. The tsunami caused huge devastation and even damaged a nuclear power plant. Let's now look at how these tsunamis happen in a bit more detail. They are actually quite similar to a normal wave in the ocean. They have the same structure. It's just the size and speed that are much larger. Normal waves are caused by things like gravity and the wind, but tsunamis are caused by a sudden large event under the water. Earthquakes aren't the only things that can cause them. They can also be started by volcanoes under the water, an underwater landslide, or even a large meteorite coming from space and crashing into the ocean. However, it's earthquakes that are the most common cause. A magnitude 9 or above earthquake is something with incredible power. The earthquake that caused the 2004 tsunami in Indonesia was a 9.1. This is the same as 23,000 nuclear weapons, each as powerful as those dropped on Japan during the Second World War. The power of the earthquake, the power of 23,000 nuclear weapons exploding under the sea, is enough to lift the water up above the normal level of the ocean. The water is pushed up by the power of the earthquake, but then gravity pulls it back down. As gravity pulls it down, the water is pushed down and sideways, outwards into the ocean. This creates an enormous wave, a wall of water. It can travel at up to 300 miles an hour, which means it can cross the entire Pacific Ocean in less than a day. How fast the tsunami moves depends on how deep the water is. If the water is very deep, the tsunami will move very quickly. If the water is more shallow, the tsunami will move more slowly. As a tsunami gets closer to land, the water gets shallower and shallower. This means that the tsunami slows down. But it also means that the energy in the tsunami has to go somewhere. The energy can push the tsunami up, creating a huge, tall wave. Usually, a tsunami that has been travelling at very high speeds out at sea can slow down to about 30 miles an hour when it reaches the land. This means that a wave can be pushed up to a height of up to 30 meters high. The exact height of the wave depends on the geography of the land. Some things like a harbour or a river can focus the energy of the tsunami into a smaller area. In fact, the word tsunami in Japanese actually means harbour wave. However, although it may be shown as just one big wave in Hollywood movies, it's actually a huge wall of water. Behind the wave is an enormous amount of water. It's more like a tide or a flood than one big wave. Because they're like a tide, they're sometimes also called tidal waves. One sign or clue that a tsunami is coming is that the sea can retreat or move back first. During the 2004 tsunami, a young girl from England who was only 10 years old saw the sea move back in this way. She told her parents that this is what happens when a tsunami is coming. Her parents then told the other people on the beach, and they managed to escape in time, saving many hundreds of lives. This girl had learnt about tsunamis in her geography lessons at school. Like with earthquakes and volcanoes, scientists are trying to learn how to predict tsunamis before they happen. If we could do this, we could give people living near the coast warning and give them enough time to get to a safe place. At the moment, however, everything we know about tsunamis comes from having studied them after they've happened. We're still not at the stage where we can predict them and give people warning. It's the speed of the tsunami that's one of the main problems. Once an earthquake happens at sea, the tsunami immediately starts moving across the ocean at an extremely high speed. There's very little time to get to a safe place.